Excellent. So good morning, everyone, at least in Mountain Time and Pacific Time, and farther west. I'm Bill Ferris. I'm the Associate Laboratory Director at the National Renewable Energy Laboratory in Golden, Colorado. And I wanted to spend a few minutes with you and kind of talk to you about what's happening on the energy frontier, what's coming in the future, and potentially get you excited about supporting an energy prime with AFWERX. So what gives us some credibility and who's NREL? So NREL is the primary laboratory within the US Department of Energy set of laboratories focused on renewable energy, energy efficiency, grid mobility, you name it, kind of the energy systems of the future. We have about 3,000 staff. We're located in Golden, Colorado. We've got a world-class laboratory that's funded by the US Department of Energy. But we focus a lot on the research from the Department of Energy and simultaneously with partners engaging with the folks who are actually going to put the technologies, the energy technologies, either into the marketplace or into broad adoption. And we also have a campus that is a model of energy-related technologies. We kind of eat our own dog food in that regard. We do the research on new technologies and we implement them in our own research facilities. So I'm going to give you a couple of teasers here. Here's how we see the future in 3 really quick sound bites. One, integrated energy pathways. We think anything that's going to be electrified will be electrified in the future. So this is mobility in buildings and almost everything you can imagine that might be using a hydrocarbon today may be using electricity in the future. The second thrust we see coming is that with the availability of relatively low-cost energy, okay, National Renewable Energy Laboratory, Energy Future, trying to excite you about an energy prime. A little bit about NREL, I gave you the high points. I was in the middle of talking about how this is going to be a game changer in terms of this middle thrust area. With low-cost electricity, small molecules, gases, will be able to create materials of the future. It's going to be a completely different way to make materials using energy and some chemistry. Fascinating and uses energy in a unique way, but opens up new possibilities. And then the final idea is we're not going to be able to use those materials once and then landfill them. We need to be able to extract the valuable components of those materials and use them for a second and a third life. Big thrust area for us. Energy is going to be a major component of that. So why does NREL have some credibility and what do we kind of see coming? Here's a really good example. As a laboratory, we've been working on photovoltaic materials for almost 40 years. We've produced the world's most efficient PV materials in terms of conversion efficiency, but they're very expensive. They're in unique space applications today, and the price and performance match that market. But imagine if you could have that same efficiency at very, very low cost. What opportunities could open up? Think of UAVs, think of other energy-related systems where a lightweight material, very low cost, would be a game changer. We're working with the Air Force to develop these new materials. Also, one of the things we see is the complexity that's going to be coming in the future. Not only is it going to be, like in the past, a few sources of generation and a relatively simple, all things considered, microgrid system or a national grid system. In the future, there are going to be millions of individual devices all being electronically controlled on the grid. How do you control that system? How do you test those technologies? We have the lab to do that. And then also there's a cyber layer to this. As energy technologies are rapidly evolving, people are thinking of the feature set around those technologies. What benefits are available with those new technologies, low cost, distributed generation. But the cyber dimension is underappreciated, and it's an area of emphasis for us, and it's certainly an area of emphasis for the military. Just being able to control all those energy systems and do it in a safe and secure manner. And then finally, to wrap up, we're a laboratory. We have our 3,000 researchers and all those partnerships that I mentioned earlier. We really see the opportunity to de-risk technologies as a laboratory. That's what we focus on. But we work with partners who will take those technologies out into the marketplace. There are a couple of examples here. I'll walk you through 2 that I think are particularly interesting for the military applications. potentially. We're working with Shell and with Wells Fargo, where we find really exciting new technology-based companies. These are startup companies that otherwise would be out there struggling to get government grants and maybe fund themselves or even get venture capital funding. We find these talented companies in the energy space, bring them into these programs funded by Wells Fargo and Shell, use all the lab resources to advance those technologies to the point where they've been de-risked and they can be demonstrated in the real world. This is a kind of a game-changing way to advance technologies. And we're talking with some partners in the military for the opportunity to build a program like this with defense-related technologies, getting things into the pipeline much faster. And as a final teaser, if you're ever snowed in someday this winter and you want to go peruse the NREL.gov website, we've been building an information data set for the full history of our laboratory, energy technologies, past, present, and future, techno-economic analysis. It's a deep, deep resource, and you should take advantage of it. So enjoy talking with you today and love the idea of an energy prime in the future. That's it for me.